Hello everyone. Let me start the session. First of all, let me introduce myself, Andreas Barnowskis, founder at Katana Machine Learning, Oracle expert at Samurai Consulting, and today's session will be about machine learning applied, contextual chatbots, Oracle Chat, TensorFlow. And I would like to say thanks for this opportunity to Oracle Groundbreakers team. So thanks for posting my video recording on Oracle Groundbreakers channel. A few words about Red Samurai. We are Oracle experts team focused on Oracle development tools, Oracle Cloud, machine learning, and open source. So the main goal of this session is to explain how to build your own chatbot with machine learning. So there are different solutions from various vendors related to chatbots. Oracle provides Oracle Digital Assistant product on cloud, which is great, and you could use to build chatbot functionality, which could be integrated into your application. Then different other vendors also provide solutions for digital assistants. Then there are some solutions offered by open source community as well. But my goal is not to talk about ready framework or a ready tool which you could use for chatbot, but rather I would like to explain how you could build from the ground your own chatbot with such library like TensorFlow. Also, I'll be using Keras for machine learning model training, and I'll explain how you could implement backend with Node.js to handle chatbot context, and finally how to build UI with Oracle Jet open source JavaScript development toolkit. So the agenda is first of all we'll go through technical architecture, then we'll demonstrate the solution, and also we'll explain essential machine learning implementation points. So the technical architecture of the solution that will be explained is divided into four main parts. First one is machine learning, TensorFlow, and the TensorFlow is used to build a model which would help us to classify the sentence that user types. And basically, we would get intent out of the sentence. So before, there's an initial step where we train the model based on sample sentences, and we map those sentences with expected intents. Model is constructed, and afterwards, when user types new sentences, then the model is trying to match the sentence which comes with the expected outcome, which is intent, and then it returns intent, and based on the intent we decide what to do and what to display to the user. Basically we decide the output which will be sent to the user. Then we're using Flask Python microframework, which helps to annotate Python function and expose this function through REST, so that machine learning model which was trained is being accessible from the outside. So we could call the API from the outside, and since we're actually running TensorFlow in a Docker container through Flask REST API, we can call it from anywhere else, from the third-party application. So machine learning does classification, and then what is important is chatbot context, because for the use cases in enterprise, it's not simply enough to classify the text and understand to which intent it belongs. It's very important to maintain the context. So if user enters into the flow of searching for the patient, for example, then in order to find the patient, maybe we would need to ask additional information from the user, and in the next, like in the second, third step, and so on, maybe our backend would send additional questions to the user, and depending on the answers that will be provided, the flow will continue. So this is called the context. So at some point, when conversation enters the context, then the next answer should be treated in a context and until the end, right? So this means actually only initial step will be classified, and then as soon as we would identify that we are in certain context, then all the subsequent requests coming from the client, we actually don't need to classify them because we already know that we're in a certain context, and then we enter the loop, for example, some sort of a flow, and we ask the user what will be the answer for question 1, question 2, question 3, and then when user answers all these questions, then we do the processing and return the result. So this is the context, and it will be maintained in the backend, and in our case with Node.js. We're using Socket IO for asynchronous communication in both ways, from the client to the backend and from the backend to the client. So the message, the backend at any time can push message to the client and it will be displayed. And in the same time, client sends the message to the backend, and once the response is built, it's being sent back to the client. For the client side, for the chatbot UI, we're using Oracle Jet, JavaScript toolkit with very rich set of UI components, and it's open source, and it's kind of I'm using it in all projects because it makes it simple to build JavaScript UIs with JavaScript, since it comes with many predefined, very nice UI components. Also, the structure is very clear and it's easy to learn it, and it's quite quite fast. You developer can be productive with this toolkit, so I like it. Right, and then if you would look more broad into the architecture of the solution, actually I'm running this assistant or chatbots, right, in the context of Docker container, and this Docker container comes with different libraries for machine learning, like XGBoost and so on, and all those libraries are packaged in Docker container, and TensorFlow is one of the libraries there, and it helps us to build the model, to classify the model, which would help to classify the inputs that are coming from the chatbot. Right, and the key thing is also API, as I mentioned before, which is implemented with Flask, so that we don't simply train the model and keep it there. We expose the model functionality to the outside through the Flask API. Right, and it's also important for chatbot or assistant not to be isolated, so it must be easily integrated into the third-party application. So the idea is that assistant should be able to route the logic flow in the application. So think about it like, instead of having complex menu structure, you may have assistant which would react to the questions from the user, and depending what user wants, the assistant would bring a certain form or certain functionality from the system, and would ask to enter additional parameters. Then based on these parameters, it would do certain action, and for example, it may search for the patient information. Then additionally, it may bring previous lab results for patient and suggest what next lab results should be entered, and then open the form that is required to capture those lab results and so on. So instead of the idea of assistant integration into the enterprise application, in simple terms, can be understood as the way you would eliminate the complex menu structure and navigation through the application, and streamline it through the direct assistant or chatbot operation. And in order to make sure that this integration would work, we would need to our main application to be able to react to the events that are coming from the chatbot and route the logic accordingly. Okay, so chatbot context. The chatbot context you can define in many ways. The simplest way is you can think of is to use JSON structure, and in JSON structure you can define relationships. So you may have like a main intent with a set of sample sentences that are actually mapped with that intent, and then if this intent is identified, then you may have like a child records with different intents, and you may have all of those child intents may have sequence. So then you may execute first, second, third, and so on intents, and kind of enter the flow. And until the flow is finished, then you always stay in the context. Right, and the entry in chatbot data usually is structured into the tag, which is the unique name, then the patterns. This is the set of sentences that would identify certain intent, and finally you may have a list of responses. So then this means when certain intent is classified, instead of always returning predefined response, you may randomly choose from different responses and return them to the user, so it would look more dynamic. So solution walkthrough. In a minute I'll go through the solution and I'll explain how it's being implemented. And this probably would be the core part of this session. So what you would see at the end, you would see the UI, which is implemented with Oracle Jet, and on the right side you will have a block where user could type sentences, and chatbot would react and provide guidance and execute some events in the application. Okay, so let's do solution walkthrough. For that, I'll switch first to the Jupyter notebook, to the machine learning part, and then would go to the backend side, and after that we'll go to the UI, to Jet. So let's see first how machine learning model is implemented. So this is training data, sample data that I'm using, and the key thing to stress here is that there's no need to have like a huge set for training data in this case, because what we're doing, we're building model which would react to certain patterns, and based on those patterns it would identify intent. So if in most simple way you may have just few intents, that's still fine. So this means your model would learn to identify only those intents, and if a user would ask something else, the model will not be able to answer that. But this is because the model was not trained to do that. So as more intents you have, as more patterns you provide to the model, then the model becomes more and more intelligent and could react to a broad range of questions. But again, if for this simple example here, there was no goal to like a bulletproof model which would react to any questions. In this case, I'm focusing on specific domain, patient search and hospital search. I tend to just have only a few intents with some sample patterns, and I'll show how the model is being trained to react to this kind of data set. So I'm using here a library called Keras, which wrapper on top of TensorFlow, and it helps to interact with TensorFlow in more simple way and more intuitive way. So it's actually quite helpful wrapper library, and in the background I'm using TensorFlow to build the model, and out of the intents that I used for this exercise. So first of all we do imports for all the libraries that are required here, then we actually reading intents file with data that will be used for training. And then before doing the training we need to clean up and prepare the data. So we split data into the words, documents and classes. So in this step we create vocabulary which will be used for training, right? And what's next, we prepare the data, because what is important to understand that TensorFlow or any other machine learning library, it cannot operate with words. It can operate with numbers, and we need to encode our words into the arrays of numbers. So with the most common way to do encoding in natural language processing is to encode words with arrays of zeros and ones. So basically speaking, you may as many words you have in your training data, this is the vocabulary, and this is the size of the array, so total number of words. And then when you select certain sentence, you compare each word of that sentence with the array, with the vocabulary array, and then in certain position, as soon as you find the word from the current sentence, you put 1, and then again you pick the second word, and then as soon as you find the second word in array of words, you again put 1. So in this way, for each sentence you create array of which size is equal to the total number of words, and this array is built with zeros and ones, and 1 is the number which is matching position of a certain word in the array of all the words. So to to understand it, when you run the code, you can just, for example, print. You could print, for example, training data for the X input, and you see the outputs. And this is the first pattern, and it represented by array, and the length of that array equal to the vocabulary size, and then probably the word from this pattern was first word was found on position 3, then the second word was found on that position, and so on. So okay, so this is the input for the X, and then the Y is in list of intents, and intents are also translated to the array of 0 and 1 in a similar way as the patterns are being translated. Okay, so here we build the training data. Then in the next step, with Keras we set up neural network layers. So in this case, we are using 3 layers. First one have 128 neurons, and the input shape is equal to the vocabulary size. Then the second layer is 64 neurons, and the third one is the output layer, which helps us to identify the intent, the one which corresponds to the current input. Right. And most often 2 layers are enough. So this is the common practice for the NLP, that usually 2 input layers are enough. And you, depending on the input data, you may play with the number of neurons, and this is the best result is found by try and error. So there's no single best practice recommendation what shape you should use. Depending on data, you should try one configuration, another configuration, then compare it and pick the best. Okay, so we build the network in that step, and then the next step we compile the model, and using a stochastic gradient descent with Nesterov accelerated gradient, which gives good results for the model based on that particular intense data here. I was using other options as well, but the one with stochastic gradient descent was giving the best result in that case. That's the reason why I picked it for this scenario. And finally, once the model is constructed, I'm running fit operation, and fit operation it helps to map input with the output and build the model. So there are 200 steps. So in 200 steps it tries to find and optimize the result. We may try to maybe from the first time it would not be the best result, and we may try to run it a few more times. So the current loss is 0.02. I think we could optimize it a bit more. So let's run it one more time. Okay, now it's quite good, 0.0014. The model is constructed, and now we can test it. So we define two other functions that help us to translate inputs string into the array of 0 and 1. Okay, and then using some sample input sentence load blood pressure for patient. And it shows how this sentence is being translated into the array of 0 and 1 based on the vocabulary. If it doesn't find the word in the vocabulary, it would be 0, and it puts 1 only for the word that is located in the vocabulary. And this means that the sentence that user would type, most likely it will not be 100% matching the sentence from the patterns that we were training our model. And this is the beauty of machine learning, because it doesn't need data to be exactly the same. Data will be different, but the model will return probability and find the intent which is most likely related to the sentence that user is typing right now. Okay, so these functions are working, and then we are constructing a sample data frame out of that sentence, right, and executing model predict operation, and we see the outputs are being calculated. Fine. So model is constructed, then we can save it to the so-called pickle, so that we'll be able to reuse the same model in the future without retraining. And also we are saving data that was used to train the model. Okay, so our model is built, and in the next step we could go to the another Jupyter file called endpoint, Katana Assistant endpoint, and I'm on purpose not using single Jupyter file but two, because I prefer to train the model in one notebook and run the model from another notebook in order to be to achieve better usability, because I don't need to retrain the model every time when I start and stop the API. I want to use the same model again and again. So here again importing Flask so that I'll be able to expose REST API. Then I'm loading the model. Also starting up two functions, helper functions to translate the input. And then again testing that input is translated well. And yeah, actually here initially I was loading data that was saved before in order to extract words and classes. So based on the words and classes, I'm able to translate the sentence that comes into the array of zeros and ones. And in this step, finally, I'm loading the model that was built before, and I'm defining the function just for a test to see if classification is working fine or not. So this function, what it does, it executes, it prepares the input, then it executes model predict function, gets back probability, and then it iterates from the probabilities, and it picks the probability that most likely represents the intent, and then it returns the intent out of the list of intents that is matching the one that was suggested by the model. Like so, for example, if we try to classify hello, good day, So it finds that it's like 100% is equal to greeting. And then if we try to classify how you can assist me, then it says like 99% that's options and so on. Right, and once you'll be loading and running this code on your machine, you could try to run other sentences as well. And as I mentioned, this function is just for a test to make sure that the model is working. And at the end is a function which is annotated with API, and this function is being initialized and it's exposing API through port 5001 to the outside. Basically, inside the function is exactly the same as the one as we were testing now. The only difference that is being annotated by Flask API and it's callable from the outside. Okay, so that's about the model. And now if I would switch to the backend side, I would show you that we're using Node.js to maintain the context. This is the backend application. And by the way, all the source code is available on the GitHub. It's open source project on this URL. And here we have in the models package, this is all machine learning stuff that you would run. And we have here all the step-by-step instructions, how to start and run everything. Then backend Node.js application is inside backend package, and UI is inside front-end Jet package. So this is the UI part. And all the source code is available as open source under this URL. So in the backend, I could go to the routes and this assistant JavaScript file, which once started, it starts Socket.io interface, and it listens for the input connections, incoming connections, and then as soon as it comes, it checks if we are currently not in context. Then it tries to execute API from the Katana machine learning, and it tries to classify the sentence, and then it finds the intent that was returned back from the machine learning and constructs the response to the client and then sends back the response, which will be displayed on the client side. On the other side, if we are in the context right now, so classification is not required because we know that we are right now in a flow, and step by step we execute we move forward in the flow from one step to another and ask user for different inputs. So the context is maintained in the backend, and UI is implemented in this Jet application. So the chatbot block itself is implemented as or is Jet web component. So in view model.js, we have logic that renders UI, and it handles buttons like send. For example, it sends a message to the backend for the classification, and then it gets back a response. Here it constructs new message that should be displayed and displays on UI. And this web component is exposing a few methods that we are actually listening in our application. So if I would go to the dashboard.js, I'd see that there's a handlebot method here. And if I would go to the dashboard.html, I would see that dashboard.html includes web component bot client, the one that I was showing a few seconds before, and this web component provides on handlebot method handlebot. Right, so this is the method handlebot, and each time when a response is received from the bot, if the response contains certain intent, then handlebot is executed, and based on logic here, it does some switch and it loads the form. So if bot returns that right now intent is adverse drag, then it comes here and it's switching logic to the adverse drag, and technically it's loading the form which is mapped with this adverse drag topic. And this is just an example. You may implement more complex functionality here based on the answers from the bot and do some pre-processing. You can prepare parameters and open form with the parameters and do auto search and so on, different stuff. Whatever makes sense for the use case and for the system. Okay, so now let's see how everything runs. So first of all, I need to start machine learning part. And first of all, I need to execute this endpoint that I was showing here, the one that is using Flask to annotate classify function. So I could start it directly in Jupyter, it would work, but I usually prefer to start from the command line as a separate process, because it makes more sense and so it's closer to something that you will use in production, because you would not start your machine learning model through the interface. Typically you would do it through the script. So in this case I should go to the Docker environment, the one that runs all this machine learning backend. Here we're using our own product called Katana, and Katana wraps all the complexity from machine learning and into the Docker container, and it helps to run your machine learning model API and backend API as well, and so that third-party application could subscribe to that API and just send the inputs and get back the outputs, and there would be no need to worry about complex machine learning stuff. Right, so now we are in the context of this Katana Docker, and I see that I have access to the same endpoint file as I saw on UI, and actually before doing this demo I converted the Jupyter notebook into the Python script so that I could start it from the command line. Right, and I'm using PM2 node processor, which helps to start the process separately. So it would not start as a root process, would not block the entire environment, and process would run in parallel, and I could start additional process, one process, and I could exit from the Docker, and process would still be running with PM2 manager. Okay, so I start Katana Assistant endpoint, and this opens Flask API on port 5001. And the next step is I need to start Node.js backend, which maintains the context. And if I would go to the backend and open Assistant.js, I would see that this backend, it actually talks with machine learning through port 5001. And to start the backend, I would need to navigate to different folder. It's called backends, right? And Node.js application, and here I start backend on port 3000. So two processes are running, and to do some monitoring I could go to PM2 monit. So that opens monitoring, and it shows information about running processes, and as soon as I'll be starting executing those processes, I'll be able to see the logs here in this main window. Okay, so backend is running, machine learning model is running, and now I need to start UI. So inside socket your jet application, I have everything ready here, And I could use OJet utility, which helps to start application with serve command, and I'm starting application on port 8010. Okay, so Jet application is running. I should open the, say, log window. Socket is connected. This means we are connected to the backend. And if I go to the process, I see that user is connected. Right, so we could try to execute, to enter some sentence to the bot window and see if intent would come as expected. So for example, if I say something like hello, good day, it reports that intent is identified as greeting, and bot message is returned hello, thanks for asking. Right, so this is correct. And if I would go to the PM2 log window, I would see that it reports that Katana assistant endpoint actually classified this intent as this input as intent equal greeting with probability 1-0. Okay, so let's type something like, for example, how can help me, and I made this mistype on purpose so that I'm not typing exactly the same sentence maybe as it was in the intent, because machine learning models still could identify it if it's similar to the original intent, and with 99% it identified that actually this is options, which is correct, and it tells me what it can do. Right, so then I could say maybe get me to adverse medicine form, and what it does, it finds out that we want to go to the adverse drug reaction model, and it opens that model. Here is some dummy data. And in this case, what happened is bot actually sent event back to the main application, which was triggered by handle, where the handle bot method was triggered, and it found that current intent, which was identified, is equal to the adverse drug, and based on the logic which was implemented in the main application, we navigated to that model, adverse drug. And how this handle bot was invoked, we can double check in viewModel.js. There is a method called socketOn, which listens when response return back, some responses coming back from the backend. Right, it constructs the UI, which is displayed inside this dialog, where all the prompts and messages are displayed, and conversation and so on. And at the end, it constructs the payload and executes custom event handle bot. Right, and this handle bot event is being then subscribed by the application itself outside of the web component, and this is where the custom logic is executed. Right, and by the way, Jet web component until now I was showing the JavaScript part, but it comes with the HTML too. So this is where the block which represents the assistant UI is being implemented. So with this HTML stuff. Right, and what I like about about Jet, that the code that which you built with Jet is very readable, and you can write very structured code. And in this example, I'm not using TypeScript, but Jet also supports TypeScript, and if you want, you could build your logic with JavaScript through TypeScript, which may improve and speed up complex forms implementations if you want. Alright, so let's back to the bot here, and maybe let's see how it works with a few more examples. If I say something like maybe what if I want to see the place to log blood pressure, for example, and it would navigate to the blood pressure model with some dummy data here as just example. And what if I want to say that I maybe bring blood result for patient, and in this case it needs to know some information about the patient, right? It cannot just bring any result. And we enter into the context, search blood pressure by patient ID, right? And I can say that will be ID 1, 2, 3, 4, 5, and then it loads some data, dummy data here for the patient 1, 2, 3, 4, 5. So this is how it works in the context, and there was no need to classify this input anymore because we were already in the context. And another example would be maybe if I type blood pressure monitoring in hospital, and then it finds that we're actually talking about blood pressure, and it navigates to the blood pressure model. And let's see if I would type another sentence like look up for hospital to monitor blood pressure. In this case, it finds out that we are not talking about blood pressure, but we are looking to find the hospital. And if I switch here, it finds with 99% that we are talking about the hospital search. And it enters the context, search hospital by params, and type some ABC here and some provide hospital type, and then it navigates to the hospital search model. And so this is how it works in the context. And then once the operation is done, we can type anything like thanks, and then it understands that we are already out of context, and then it starts to classify this input, finds that this is the intent thanks, and returns back the response. So this is how it works. And if I would switch back to the PowerPoint and would go through some machine learning stuff, so it's important to understand that machine learning is highly depends on the training data. So as rich data you have, then probably the best the classification result will be better. So it all depends what kind of use case you want to achieve. And if you're building assistant or chatbot, so your training data must have close to 100% of the use cases that you would expect that users would ask your assistant. So as more examples and patterns you have in training data, the more accurate assistants will be in the future. So you have training data, then you convert the training data to the structure that can be understood by the machine learning algorithm, because sentences and text directly they cannot be understood, and you need to translate to the arrays of zeros and ones and do encoding. Then you feed this data to the learning algorithm and build the model. Afterwards, as soon as you have the model, you actually also you can feed the data, that new data that comes from the users, and model does prediction. It tells you, finds you the intent, the one that it thinks that this input belongs. And there are two major types of machine learning, let's say, tasks. The first task is regression, and the second task is classification. So in regression, you may have inputs as discrete and continuous, and regression would always give you continuous outputs. So what it means, it means that regression is mainly used for the forecast, and forecast it could be approximate, right? And with regression, out of the existing data, you try to find a line that would represent the structure of the data, and then you may forecast the new point where it would belong with the parameters that belong to that point. So in machine learning, the key elements are the cost function, which shows the sum of errors in predicting your input, and the higher the cost, the worse the model parameters will be. So you need to make sure that the cost function returns the error as small as possible. This means that the model training quality will be better, and in the future it will do a better job in classifying the input. Also, you need to define the number of steps or loops the model is trying to find the best result. So it's not always good to set this number to some high number of steps, because you may reach a station where overfitting would happen, and then the model would work well with the training data, but with any new data it would not be able to classify it properly. So again, this is something you achieve with trial and error, and you need to do experimentation and see how it works with different set of parameters. And learning rate, the higher learning rate, then this means the learning would run faster. The smaller learning rate, this means the learning would run slower. And also it depends on the data. Sometimes you may need to have faster or slower learning, and you need to compare the results with both values and see which one works better for your data. So in regression example, you can be explained by linear regression when you have equation like x equal w multiplied by x. So the task of regression is to find w. So based on the current points, it would try to find the line that represents the points in the best way. And in order to solve this expression, machine learning could try to find w, and then as soon as you know w, you may, for any future x, you may find y, the result of this function, quite easily just by multiplying it. So this is the simplified example, but you may have not line but curve or multiple dimensional data and so on. But this is the simplistic example of regression. In classification, we also may have input as discrete and continuous, and with the classifier we would produce output which is always would be discrete, and the output would identify the class. So in our case of assistant or chatbot, the output would be intent. So based on the user sentence, we would identify to which intent it belongs. And the best classification example, when you have like two types of data, red and green, and then classification algorithm would try to build a model which splits this data, and so that in the future it would learn how to identify the future point where it belongs to either green or red group. And I'm using TensorFlow and Keras because TensorFlow is one of the best and well-maintained open source libraries for machine learning, and there's a lot of support online, and you could go through the forums, and if you have any problem, or most likely you'll not be stuck, you already find the answer, someone else facing that problem and getting the answer from another community member. Right, so my contacts, if you would wish to get more information or if you'll have some questions, please get in touch, or either on Twitter, send email, or visit us on website katana.ml.io. References: the source code is available on GitHub under the Katana ML organization and Katana Assistant repository. There is a blog post as well from myself, which explains in more step by step how to run the source code, and again it explains different parts of backend machine learning and UI and how it's being done. And the slides that I was showing right now are available on a slide share and under this link with bit.ly. Right, so thanks, and once again, if you want to run it yourself, then go to the GitHub Katana ML, Katana Assistant repository, and just clone it and run model. Then you run backend, and then you run UI based on the README instructions presented here below. Thanks, and we'll be in touch in the future. Bye. So at the end, I would like to say thanks to the Oracle Groundbreakers program and team. Thanks, guys, for your support, and thanks for allowing me to publish this video tutorial online with Oracle code. And I would like to mention that I'm Oracle Groundbreaker and Oracle ACE Director, and encourage everyone to check Oracle Code YouTube channel, to go to the Oracle Groundbreakers online material feed and stream, and get the latest and greatest information from the program about Oracle technology. Thanks.